In my last video, what we did was we looked at how we could add vectors. So if I had one vector that was vector x, and I had another vector that was vector y, we looked at how we could add these two vectors to figure out what the resultant vector of these two vectors would be. So what we ended up doing was we ended up using the parallelogram law. We added these vectors together, and then we would use the law of sines and we'd use the law of cosines to determine the angles in this parallelogram and the side lengths of the parallelogram. If you don't know what I'm talking about, I suggest you go look at my previous video, and I do an entire example using the parallelogram law, the law of cosines, and the law of sines. So in this video, instead of giving us the two vectors x and y and determining what our resultant is, I want to give us our resultant. So I want to give us this resultant r, and if I can draw this correctly, I want to figure out how this resultant r can be broken up along two different axes. So let's say, just in a general case, how it can be broken up along this axis and this axis. So what we're going to be doing is we're going to be finding this vector. I think that's a little high, but that's okay. And we're going to be finding this vector. And this would be our vector x, and this would be our vector y. So that's what this video is going to focus on. Now, I'm going to show that with these two examples right here. So this is going to be my example A, and this sort of looks like what I just drew, except it has some numbers to it. And then I'm going to show you it doesn't need to just be along the x and the y axes that we typically use in engineering. It can be along any axis that are specified. So in order to do this problem, let's first look at what we're given. We're given a 100 Newton force that makes a 40-degree angle with the x horizontal axis. Now, this, like we said before, we're going to be looking for this vector. Let me choose a different color that contrasts a little better. So we're going to be looking for this vector, and we're going to be looking for this vector. Now let's give them some names. So this will be f of x, and this one right here will be f of y. This is a sort of simpler example because what happens is this becomes a right triangle, and because it's a right triangle, we can use the Sohcahtoa method. With this Sohcahtoa method, we know that theta is going to be equal to 40. We know this is going to be our adjacent side, so let me just write a little a. This is going to be our opposite side, and our hypotenuse is going to be equal to 100 newtons. So if we substitute in what we're given with Sohcahtoa, first let's say we're going to find f of x. Remember, it's a vector. So we're going to have to use the cosine in Sohcahtoa. If you don't remember how to use Sohcahtoa, this cosine is the c. So we have the cosine of 40 is going to equal our adjacent side over our hypotenuse. We know what our hypotenuse is, and we're looking for our adjacent side. So our adjacent side is going to be equal to the cosine, it's going to be equal to h times the cosine of 40. So if we can substitute in our numbers, we're going to get f of x, which is adjacent, is equal to 100 times the cosine of 40, and this is going to be equal to 76.6 newtons. Next, we're going to find our f of y, and we're going to do the same thing. Instead of using cosine, we're going to use sine. So we're going to have 100 times the sine of 40, and this is going to be equal to 64.3 newtons. So this right here is our example, is our answer. 76.6 newtons is this vector, and 64.3 newtons is our y vector. So this example was a little bit simple because this turned out to be a right triangle. Now, if you're doing homework or you're doing an exam, it might not turn out that you're being asked to decompose the resultant along the x and the y axes. You might be asked to decompose the resultant along different types of axes. So in this example, so the second example, so this will be B. This also needs to be 100 newtons. I want to decompose it along the y-axis, and I want to decompose this 100 Newton force along the x prime axis. And this x prime is going to be located 30 degrees below x. So the first thing I want to do is look at sort of what I'm looking for. So I'm going to look for a vector that's along this axis. And I know the vector right here goes completely straight up because it's along the y-axis. So I'm going to have a triangle that looks like this. Now if I redraw this triangle, so this is 100, this is 100 newtons. I don't know what this length is, so I'm just going to call it f of x prime, and it's a vector. And I don't know what this length is right here, so I'm going to call it f of y, and it's also a vector. Now I know this angle right here is 70 degrees. This is going to be the 40 plus the 30. And I can figure out what this angle is right here. I know it's going to be 50 degrees. I know this is going to be 50 degrees because x and y are orthogonal to each other. So they're 90 degrees to each other. The resultant is 40 degrees up from the x-axis. So this right here is going to be 50 degrees. This y-axis and this y vector I'm looking for are both completely vertical, so they're parallel to each other. And this 100 Newton resultant force intersects both of these, or touches both of these parallel lines. So we know that these interior angles right here are going to be equal to each other. So that's how we can tell that that angle is 50 degrees. Now the last angle right in here is going to be 60 degrees. And we know that because we know a triangle needs to have 180 degrees. We know this is 120 degrees, so 180 minus 120 is 60 degrees. Now, in this example, we can't use Sohcahtoa because it's not a right triangle, so we need to use the law of sines. And what it is the ratio of the length of a side to its corresponding opposite angle. In our case, f of x, f of y, 100 newtons are length of our sides. This sine of y corresponds to these different angles. So let's look for f of x prime first. F of x prime is across from the sine from 50 degrees. So here is going to be the sine of 50. So this right here is across from the 50 degrees. And we're going to use this 100 newtons side. This is across from 60 degrees. So our answer, if we evaluate this equation, is going to be 88.46 newtons. Now we can also do the same thing with f of y. We don't know what f of y is. Its opposite angle is going to be the sine of 70. And this is, again, going to be equal to 100 over the sine of 60. And this is going to be equal to 108.51 newtons. And this are the lengths of the f of x vector and the f of y vector. So a couple notes about this problem. After we had found this f of x prime right here, yes, we could have used this 88.46 instead of this 100 and the sine of 50 or instead of the sine of 60. However, if you had made a mistake finding the f of x prime, this mistake would have carried over then, and you would have then made a mistake finding the force of f of y. So that is why I use this 100 over the sine of 62 times. The other note I'd like to make is we were able to use the law of sines for this triangle because this triangle was defined by angle, 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 which means it had a unique solution. In my last video, I said don't use the law of sines to find the length because when you're doing the parallelogram law, what happens is sometimes the triangles are defined by a side-side angle, which creates a non-unique case, and I talked about that in my previous video.